4.4 Hess's law. The enthalpy changes for some reactions cannot be measured directly. To find these, you use an indirect approach. Chemists use enthalpy changes that they can measure to work out enthalpy changes that they cannot. In particular, it is often easy to measure enthalpies of combustion. To do this, chemists use Hess's law, first stated by German Hess, a Swiss-born Russian chemist born in 1802. Hess's law states that the enthalpy change for a reaction is the same whatever route is taken from reactants to products. This is a consequence of a more general scientific law, the law of conservation of energy, which states that energy can never be created or destroyed. So, provided the starting and finishing points of a process are the same, the energy change must be the same as well. If not, energy would have been created or destroyed. To see what Hess's law means, look at the following example where ethine, C2H2, is converted to ethane, C2H6, by two different routes. So how can we find the enthalpy of reaction? Route 1. The reaction takes place directly. Ethine reacts with 2 moles of hydrogen to give ethane. So you have C2H2 plus 2H2 equals C2H6. Route 2. The reaction takes place in 2 stages. Ethine, C2H2, reacts with 1 mole of hydrogen to give ethene, C2H4. So you have C2H2 plus H2 equals C2H4. For this, we know that delta H is minus 176 kilojoules per mole. And then, ethene C2H4 reacts with a second mole of hydrogen to give ethane, C2H6. So you have C2H4 plus H2 equals C2H6. For this, we again know that the delta H is minus 137 kilojoules per mole. Hess's law states that the total energy change is the same whichever route you take, direct or via ethene, or in fact by any other route. You can show this on a diagram called a thermochemical cycle. So, to get the delta H for the route 1, for the reaction taken in route 1, you simply add the 2 values for route 2. So you get delta H of the first route equals minus 176 plus minus 137, which is equal to minus 313 kilojoules per mole. There are certain types of enthalpy changes that can be looked up for a large range of compounds. These include the enthalpy change of formation, delta FH, and enthalpy change of combustion, delta CH. In practice, many delta FH are calculated from delta CH via Hess's law cycles. The enthalpy of formation, delta FH, is the enthalpy change when 1 mole of a compound is created from its constituent elements under standard conditions, all reactants and products being in their standard states. Another theoretical way to convert ethine into ethane could be via the elements carbon and hydrogen. Ethine is first converted to its elements, carbon and hydrogen, which is the reverse of formation, and the enthalpy change is the negative of the enthalpy of formation. This is a general rule. The reverse of a reaction has the negative of its delta H value. It is in fact a consequence, again, of Hess's law. Then the carbon and hydrogen react to form ethane. This is the enthalpy formation for ethane. Using the delta H values, Hess's law, and thermochemical cycle, we can now hence calculate the enthalpy change associated with the conversion of ethine into ethane. To get the correct value, we simply add then the two previously mentioned enthalpy change values.